are among the universe is finite, which means we can win the battle. But if you're going to map the universe, you're not going to do it as one of two of your besties. Mapping the universe takes an army of curious, creative craftspeople who, working together, can accomplish the extraordinary. I lead this army of creatives in the 5th generation of the Sloan Digital Sky Survey, SDSS. And this is how astronomers have managed to shepherd individual curiosity through its industrial age, preserving the individual ability to make discoveries, but putting into place mega machinery to truly advance the frontier. In SDSS, we divide the sky into 3 mappers, one for the stars, one for the black holes, and one for the galaxies. My survey has 2 hemispheres, 5 telescopes, or 11, depending on how you count, 10 spectrographs, and millions of objects. It's a monster. So let's go through the mappers. The Milky Way galaxy has 250 billion, plus or minus a few hundred billion, stars. That is not a number that you hold in your head. That is a number that doesn't make practical sense to pretty much anybody. You never get 250 billion jelly beans in your hand, you know? We're nowhere near mapping all of those stars yet, so we have to choose the most interesting ones. In SDSS 5, we're mapping 6 million stars where we think we can measure their age. Because if you can measure the age of a star, that's like having 6 million clocks spread all throughout the Milky Way. And with that information, we can unravel the history and fossil record of our galaxy and learn how it formed. I'm just going to cut right to the chase here. Black holes are among the most perplexing objects in the universe. Why? Because they are literally just math incarnate in a physical form that we barely understand. It's like the number 0 being animated and walking around the corridors here. That would be super weird. These are weirder. And it's not just like a basketball that you smush down into a little point and it's super dense and that's weird. No, smushed basketballs have a surface. These things don't have surfaces, and we know that now because we've seen it, or the lack of it. What's really interesting about black holes is that we can learn a lot about them by studying the material just as it passes through that point of no information return. Because at that point, it's emitting lots of X-rays and optical and UV and radio waves. We can actually learn how these objects grow. And in SDSS, we're looking at over 500,000 supermassive black holes to try to understand how they formed. Like I said, we live in the Milky Way. You guys are all familiar with that. The Milky Way is a completely average galaxy. Nothing funny going on. But it's ours, which is great. We think that the Milky Way and all the Milky Ways have this really disturbing past of literally blowing themselves apart. It's like every average guy you know has a history as a punk rock teenager. That's very bizarre. Stars are blowing up in these systems. Black holes are growing at their centers and emitting a tremendous amount of energy. How does that happen? How does this transformation happen? And in SDSS, we're going to the bellies of the beast and zooming way in to look at these processes, where they are occurring, in order to understand how Sid Vicious grows up into Ward Cleaver. My arsenal. These are my 2 big telescopes. The Apache Point Observatory hosts the Sloan Telescope in New Mexico, and the Las Campanas Observatory in Chile hosts the 2.5-meter telescope, the DuPont. 2.5 meters is the size of our mirror, which was huge for Tycho and Kepler, but it's actually not so big today. There are way bigger telescopes out there. But in SDSS, we use new instruments on these old telescopes to make them interesting. We capture light from all of those objects into our aperture, and that light is then focused at the focal plane where our instruments sit and process